Okay, good afternoon, guys. This is the second portion of class design, which we're going to go through, and also the last module of this unit. Okay, so there's not a lot left. Now, what you will see, we are going to look at the last portion. Now, we've spoken about the previous things a bit. The operations, methods, states, and attributes, we spoke about them. Now we're going to look at the dependencies, association, generalization, and also to resolve use case collisions. Okay, so what you will see, there's a mention of a dependency. Now, initially when we had our relationships, which of these did we work with when we created our initial diagrams, class diagrams? We only worked with the bottom ones. We only worked with association, aggregation, composition, or even navigation. Now we're going to look at refining these. And we're also quickly going to look at dependency. Where does it come in? So you will see dependency. It tells us that it's a relationship between two objects mainly. With the purpose of this is it determines which structural relationships are not required. Now, what is a structural relationship? Structural relationship is where we have a relationship created between two classes due to an object which is staying behind. We will look at it also a bit later. Now, things that we're going to see in this, there's different types of dependencies. There's a local variable reference, parameter reference, and also a global reference. So what we're more seeing is that either the attribute, which we're passing around as part of your parameters, is the data type of it is based on another class, or the thing which it returns, or the local variable which is used, or a global reference is based on some other class. Okay. Now, your normal field reference, which we see mainly through associations, aggregation, composition, is a field which creates a relationship. Okay. Now, if we quickly look at association versus dependencies, an instance of our association is really creating the link. So, if we quickly go here, and we have two classes, let's say class A and B. How do we create a relationship? How do you create a relationship from A to B? You've implicitly done it in programming, but not realized it yet. So, what is this? Ignore the private for now. It's an object, B, which is created based on the class B. So that allows us to have the relationship, because I can now go and do this. You can go and say B something, meaning B, go and invoke the method of object B. Where is that method going to be defined? Inside the class. Okay. So that is really helping us to create a relationship really for structural relationships. But we are now also going to look at dependencies. Okay. So dependencies are really transient links. It's things which we can't directly see, and it's not directly created like in this case. It's implicitly there due to some things which happens. Now it is there for a limited duration. Then it's also context independent relationships. And it's really just a summary. So what we are seeing is that if it's a local variable reference, and we have this in our class diagram, we might have operation 1. And inside operation 1, it's a method that we have there. We might go and create an object of class B. Okay? So this object, or inside this method, operation 1, there's an object of this guy. But if I change this guy, is it going to have an effect on the object? If I change the structure, is it going to have an effect on the object? Yes. Can I quickly lend you a water bottle, Nessa? If we take this and we press it a bit, let's say this was the class. There's functionality to this. We can open it, we can drink the water, all of that. But if we change it, if we change the class, is it going to have an effect on other classes or other objects which is created on this? If we now go and change the template which they use to mold this bottle, is the rest of the objects going to look differently? Yes. Okay, so it is the same for dependency. If I go and change this class, every place where an object of it is created, it will also be changed. Okay. In an IDE, if you now go and change, and you, for example, add an operation here, or you remove an operation, and you were actually using it, let's say, for example, in here, then this class will start giving you errors because it doesn't have this operation anymore. Okay. That is where the dependency comes in. Okay. Now we also have a parameter-based dependency, but parameter-based dependency tells us that this object of class B can either be created as a parameter, it can either be a returning parameter, or it can be a parameter which is passed into that operation. Okay, so what we're seeing is this a parameter is based on the data type class B. Okay, so it's based on this structure. If this guy changes, that object is also going to be changed. Okay, then we also have global visibility, where we have class B and we have a global operation, and that is globally visible to other classes. If that is changed, it's going to have an effect wherever you have previously used it. Okay. So how do we identify these dependencies? There's a few considerations that we need to make. If there's permanent relationships which is based on our associations, they will mostly probably still be associations, but they can be refined into aggregation and composition and so on. Okay, if there's transient relationships, then that will be dependencies. If there's multiple objects that share the same instance, we can rather pass these instances as parameters, thereby creating parameter visibility, which is a parameter-based dependency. If I make an instance as a managed global class or managed global operation, then thereby creating a global dependency. Okay, so if multiple objects don't share the same instance, It is only local visibility. So things that we also might need to consider is that how long does it take to create it and then also to destroy it? Is it going to take long, thereby meaning expensive? Do we use fields or parameters or global visibility? Now we need to look for the one with the lightest relationships. Now they give us a class diagram where they show to us this was the relationships before they've identified any dependencies. Then they start to see, but here we have a student and a schedule and a schedule and so on. Now, then they start to identify, and just to say, but we're also getting field-based visibility. That wasn't plain association. But here we have a parameter visibility. Why do we have parameter visibility here? You see, we are getting for course offering, which is an object of course offering, which is passed in as a parameter to this as prerequisite operation, thereby creating a parameter visibility. Okay. Why is this being identified? When we're looking at our classes and even a class diagram, we would like to get to the place of that there is a reduced relationships. That if you change a class, that it's not going to have an overly complex effect in your system. So the next portion then talks about defining associations. Now, for this is that we might need to go and refine our remaining associations. Then that we might need to go and look at, is it still staying in association, or is it possible that I'm going to have aggregation? Aggregation then also needs to be looked at composition. Okay, then attributes versus your associations, navigatability, and association of a class. Okay, so there's quickly a bit of a review quickly on what is composition. So you'll see composition is still a form of aggregation, but there is a strong ownership and coincident lifetime between the whole and the parts. Okay. Now, we can also get to the place of having shared aggregation and non-shared aggregation. Non-shared aggregation, what it's mainly saying to us that this whole is going to have a multiplicity of 1. This part can only belong to one whole. Okay. But what we're seeing here is that multiplicity has now been changed to 1 to many. So this part can belong to many wholes. Okay. As an example, the chair you're sitting on, can that chair be used next door? Okay. So if we take that this chair is part of this venue, can it also be part of the venue next door? Yes. Okay, so what are we seeing? That in that case, we can see a form of shared aggregation. Okay. Then there's also quickly the considerations. We need to look at the lifetime of our classes. If we're looking between aggregation and composition, how do we decide, is it going to be aggregation or is it composition? They're saying that we need to look at the lifetime of class 1 and class 2. If class 1 is outliving class 2, or any object created of that class. That means that it's going to be aggregation. But if the two is created at the same time and they are depending on each other, then it will be composition. Okay. So here's an example where we have a student and schedule. What we're seeing from this is that I cannot be registered or a registered student without having any subjects. Are you considered a registered student if you don't have subjects? No. So what we're also seeing is that register for courses form, this boundary class, cannot exist on its own without its controller. Okay. Any questions so far? Yes. Okay, what you are more talking about is the visibility of a class. If I create a class as private, what is the aim of that?
Only object from that class can access the...
But can other classes actually access this object? Can you create a private class? As far as I know, that you can only create a protected and a public class. Reason for what I'm saying is I don't think you can create a private one. Private means that only objects of this guy. Where do we see it a lot? We see private a lot with the attributes. So, and those are quite a lot of times public. You won't really have a private class. Why? For us to write this, let's say this was private. If we had to create an object of it, can I go and say this? Can I create an object A based on class A inside another class? If it was private? No. Okay. So if it was protected, can you do it? If it was if these two are in these two classes are in the same package, or so then, and it's created as protected, then this one can access that one. Okay, we're getting very technical about it. But then they're inside the same package. Okay. you won't really see that with composition and aggregation. Where it's going to is more looking at the relationship between the two classes. For us to create a relationship, that class still needs to be either protected or public. Okay. Okay, then they're also mentioning to us attributes versus composition, and then when to use the two. So we're going to look at using composition when the properties needs to be independent identity. Okay? Or if multiple classes that have the same properties or attributes or operations. Then if there is properties have a complex structure and properties of their own, then if properties have relationships of their own. Otherwise, we can use plain attributes. So what does this mean? Okay. Take, for example, there we have a student and a schedule. Two separate classes. Now, if we look at these previous ones, if we look at the attributes here, semester and those operations, does it belong with a student? No. It's really something which belongs on its own. Okay? But what we also are seeing is that it's a complex structure and multiple other classes might need to use it. Is there other classes who would like to use the schedule, who would like to access your timetable? What about the actual subject? Yes. If we look at your timetable, do we see the actual subjects on it? Is there a relationship to subject? Okay. So what we are in essence seeing is that the multiple other classes would like to use those same attributes or properties again. And then there is some complex behavior of its own. So we are getting to some composition structure like this. Now, that could have also been modeled, for example, Then the next portion they get to is to talk about navigation. And navigation really indicates to us that it's possible to navigate from one class to another in a specific direction. Okay, so what are we seeing? I can navigate from the controller to the schedule. Does the schedule need to go to the controller? No. Only the controller would like to go there. So, how can we decide what would be the directions? We can go and look at our possible interaction diagrams, the sequence diagrams, which helps us to discuss the direction. We can even work, even when both directions seem required, if we are getting to something like this, where it looks to us that it's a bidirectional thing, we might need to decide which navigation is infrequent, meaning what is going to be the most frequent direction of communication. Okay, and then the number of instances of one class is small. Then I will see I might need to go this way or that way. So what we are seeing is there's two different ways of modeling the top one. Schedule to course offering. And then also from course offering to schedule. Okay. Which direction is infrequent? It's not going to happen a lot. Now, but based on these two, if we just look at this one, what direction is not happening frequently? Okay, which of these is more prominent? Meaning that we are going to have a lot more queries going from this class to that class. Is it going to be more from a course offering to schedule? So meaning that for this subject, we are going to have many different schedule entries, timetables? Or am I going to go from this timetable, that side? Okay, so are you saying this one? Okay, let's look at the discussion quickly there. So they're discussing each of the ones that we have there. The total number of schedules is small, or is never need a list of the schedules on which the course offering appears. What you need to note is that in our context, the course offering is actually the subject, and the schedule is your timetable. Okay, so if the total number of timetables is small, or we never need a list of timetables on which the course offering appears. Is that correct in our situation? If the total number of course offering is small, or we never need a list of the course offering on which the on a schedule. If you look at your timetable, do we need the course offering? Yes. So it's not this one. Why is it not that one? We can have a course offering without a schedule, yes. So it will be the top one most probably. Okay. So then there's quickly a discussion about when we are going to see association classes. And association class is one which we've seen previously also, and that is really a class which sits in between two other classes. So we still have schedule and course offering, and this will then be the primary schedule offering and that schedule offering information. Okay. So what we are seeing is that the association class captures information about the relationships. This mark or grade, does the grade belong in the schedule? Or does the grade belong in the course offering? It doesn't belong with either one of the two. Where does your mark belong for the subject? Let's quickly draw this in this. Where does your mark, your actual result, belong? Does it belong in the student, or does it belong in the subject? But the subject only captures the subject name, the description. What is the multiplicity for this relationship? One student might do how many subjects? Probably one too many. But this subject may be done by how many students? Probably one too many. Okay, so that marks, where does it belong? Does it belong in student? No. It also doesn't belong into the subject. But it is a attribute. And that attribute is this talking about this instance of the relationship which we see. It doesn't really describe the student. It doesn't describe the subject, but it describes the instance. Okay. So what we are seeing is that association classes helps us to capture this information, and we see it a lot of times when we have a many-to-many relationship. Okay, that 0 to 4 is still many, although we've given it an explicit maximum. Okay, there's still a number of objects participating in that relationship. So other ways in which this can be modeled and can be designed, we might see still that we have our schedule and course offering, and that could have possibly just been modeled as a plain relationship there, but this is then broken down. Now what you will see, this was previously modeled as a class which is connected to that one with a dotted line. So if we had to do this here, we would have had this with our dotted line connected there. Now, what we are noting is that they've made changes to the relationship. Look at where's the many signs now. If we have our schedule, how many primary schedule offerings can someone take? 0 to 4. A schedule can have 0 to 4 course offerings, and a course offering can have 0 to many. If we look at this one, course offering to primary schedule offering is 0 to many. So what we must note is this one is moved that side, and this one is moved that side. So what we're seeing is this multiplicity switches around, and there's a plane relationship created there. Okay. So then there's also a matter of that we need to decide on the multiplicity. Is it going to be 1 or 0 to 1, for example? In this case, if it's something like this, then we don't need to redesign it or design it into more things. But what happens if the multiplicity is greater than 1? So what they're saying to us here, we cannot use a simple value or a pointer. There may be a need to design this more. A professor can be the instructor of 0 to many course offerings. Okay. But for us to create this relationship, if we go back to this. If the multiplicity was something like this, 0 to many, does this still count? This would have been correct if the multiplicity was just 0 to 1. How do we create now that 0 to many? By using things like arrays. Okay. So that when you model this, and then it will most probably be okay, I don't think it would totally be like this, because for an array must have a maximum value. Okay, so you can't really model like 0 to many directly as an array. But that would probably be done. Then you had to redesign the multiplicity and review the actual multiplicity. Okay. Don't shoot me about the programming. Okay. I think it's something like that. Okay. Now, what we also may see is we can also go and place containers around this. We're not going to see this quite a lot often. We don't see it so much. We can even create parameterized classes and templates. This is for especially if you try and create a template which can be reused later on, like a template class. There's some modeling of that. Then there's a instantiating our parameterized class, just an example of it. Now it will be looking before and afterwards of that. Also not something we see work with a lot. So there's an example about designing the optionality. If a link is optional, make sure to include an operation to test for the existence of the link. So what we're seeing is that we have the 0 to 1 and 0 to many. The professor can teach 0 to many course offerings. So what they are saying to us is that we need to include an operation is teaching. So is this professor teaching a course offering? Which then can be used to test, is he involved in some course offering? Okay. I went down too far. Okay. So then there's some decisions which we need to make based on the generalization. See, my voice was also on holiday. Okay. So we know that the generalization is a kind of relationship where a check account is kind of an account, and a savings account is kind of an account. So that phrase is kind of, can be used to test the relationship that we are having there. Now, then we can also have abstract and concrete classes. You've worked with abstract classes in programming. Yeah. Abstract classes is a class which cannot have an object on its own, but the children must then be instantiated. So the concrete classes can have objects, so the concrete classes are also then the here. Okay. So an abstract class is also indicated by this italic font that we see there. And okay. So then they showing to us also quickly multiple inheritance, where we have a bird, but he is inheriting from the animal kingdom some characteristics, but it's also something which can fly, so they consider it a flying thing. Okay. So then, in this case, they have a repeated inheritance where they have animated object, and then they can have an animal and a flying thing, but ultimately a bird is still considered somewhere in there. Okay. So there is some constraints for generalization that we might need to look at. Is it complete? Is it incomplete? Is it disjoint or overlapping? Now, these constraints are based on, let's say, for example, the check account. Does it capture, is there any new information which is not portrayed already as part of the parent? So there is some rule guidelines to this where the is it the end of the inheritance tree? Is there more children after this actual the children? Okay. Is it incomplete? The inheritance tree may be extended. So what we're seeing in this case, this animal, animate object, animal, bird. In this case, it was extended and a bird was added. And also, it was not the end of the inheritance tree. So it was incomplete. Now, this joint talks about it. The subclass is mutually exclusive. It doesn't support multiple inheritance. So in this case, if we had to model a line in here, let's say actual line class, wouldn't that line be considered a flying thing? No. It would just be one which is related to an animal. Okay. Then overlapping, the subclasses are not mutually exclusive. It supports multiple inheritance. So in this case, this bird belongs to multiples, parents in that case. Okay, this is also not something which you see very often, multiple inheritance in program, because you tend to want to stay away from it because it gets your structure overly complex in your class design. Okay. So there's quickly an example where they're indicating the constraints. So in this case, we have an asset, and we can see the bank account, real estate, and security. Each of these are children classes to the asset, but they are saying it cannot be overlapping. So each of these are disjointed, it's on their own. So they've added the word there, disjointed. And in this case, if we look at the bank account, we have savings and check account. Again, they've added in the disjoint and complete, because this is the end of the hierarchy. So this one must be complete. Okay. So then there's again some generalization constraints which we're seeing, and we have overlapping where we have an amphibious vehicle, land vehicle, water vehicle, but this one, in this case, it's covering multiple classes, multiple parents for us. So then there was quickly a mention about generalization versus aggregation, about when will you use it. So what we are seeing is that this generalization is represented by is a relationship, but also we're getting aggregation where the keyword is that part of it is used to test for aggregation. So in this case, we're seeing that we can even use this for modeling of user interfaces where we have a window with a scroll bar, but this is almost like a window, part of that window. Same here. So the wording between the two can become very confusing. Okay. So do you really need to use it as aggregation or composition? It can become very confusing. So what they are in essence saying to us that this can also be modeled as a window and as a parent, and the window with scroll bar can be considered a child of the window, and then we have the scroll bar, which is really just giving us a composition relationship to that, because the scroll bar is part of that window with the scroll bar. It's not part of the initial window. Okay, then there's quickly a matter of where they're talking about the shared common properties and behavior. You can have a look at this. And okay, then they're talking a bit about polymorphism. Now you'll see that's the ability to hide many different implementations behind a single interface. And they're talking about that with polymorphism. How do we implement it quickly? For example, you might have an animal, parent class, and the lion and tiger. But if we did not have polymorphism, then we would have needed to write some code in here which says if this animal is a lion, then go and do this. Now, with the polymorphism, you will just say, but this guy is communicating. You don't need to worry about the actual details of it. So then there's also a matter of the use of interfaces in your generalization structures. I think you will get to this in programming if you are doing generalization structures. Okay. So there is also some design considerations for this. It provides an interface only to your descendant classes. It provides an interface and default behavior to the descendant classes. Then if there's mandatory behavior to the descendant classes that might need to be considered. Okay. So then they also something which they talk about as a metamorphism. Now, the metamorphosis which we're seeing is that we see that quite at university where one student is migrating as a part-time student to a full-time student or a registered student compared to just a qualified student. Now, where that is going to see that what we're seeing is that the object of a student is migrating, is becoming another type of student. So what they have done is to create a type of generalization structure to say, but you have a student, part-time student, a full-time student, and you can create some type of structure for this. That's one approach. Or you can have still some form of generalization structure, but now in this case they've added a class called classification. The student have a one-to-one aggregation relationship with the classification, and the classification is then linked based on that to the part-time classification or full-time classification. Okay. Now, what we're then seeing is that with the metamorphism and the way in which they implemented, the student will directly then talk to the part-time classification or the full-time classification. There's no need to talk to the parent first in this. Okay. So there's also a matter about the flexibility of making changes to this. If we need to make changes to the structure and give it multiple options, we can just add in options to the classification and link it to more children at the bottom. Okay. So then there was just a matter of introducing how to resolve use case coalitions. Now, what is a coalition? So they're mentioning to us here if multiple use cases have simultaneous access to design objects, how are we going to handle that object is accessed multiple times at the same time? Okay. So options which we might have is we might work with synchronous messaging, first come, first serve, compared to asynchronous messaging. We might need to identify the operations or code to protect, so that you only run a section, first this section of code, then that section of code. So there might be some access control mechanisms which you need to apply, some message queuing, or even tokens which can be used. So thereby using some form of locking mechanism where you lock it out and you use it. So then there was also mention about handling non-functional requirements, and this is giving some changes to it and looking at it, and then there's also some considerations to this. Okay. There's a few checkpoints just at the end of this, where does each class have a clear name? Does it have a well-defined abstraction or form a well-defined abstraction? Is it functionally coupled and between attributes and the behavior? Does that class couple and link in the attributes and the behavior correctly? Do we need generalization? Okay, have all class requirements been addressed and demands are consistent with your state charts and the rest? Then the complete class instant life cycle is defined and the class has the required behavior. So for the operations, have your operations, are they easily being understood? Have the state been described correctly? Is the required behavior which is possibly offered? Your parameters, are they defined correctly? Then messages are completely assigned operations. Your implementation specifications are correct. The signatures conform to standards, and then all operations are needed by the use case realization. So there's also for the attribute portions of and the relationships. Okay. Guys, I hope this was quite long. Okay. But I hope this was interesting to some extent.